Hello students, in this video we'll introduce the Schwarzian derivative. If we're given two non-proportional solutions of the normal form of the second order normal form equation y double prime plus I of x y equals 0, that's our normal form for a second order linear equation. Let's call these solutions y1 and y2. I'm going to form a function, form y1 is equal to s y2, and this function s is not going to be constant, right, because they're not proportional to each other. So if we differentiate this relationship, what do we get? We get, if we differentiate the relationship, we'll get y1 prime. y1 prime is equal to s prime y2 plus s y2 prime. And then we'll also get that y1 double prime is equal to what? Is equal to s double prime y2 plus 2s prime y2 prime plus s y2 prime prime. Now we know that y1 is the solution to this equation, so I know that y1 prime prime plus I y1 is equal to 0. And so what this tells me is this expression over here, this s prime prime y2 plus 2s prime y2 prime plus s y2 prime prime is equal to negative I, and then y1. But y1 is s y2. All right, so now let's look at this part of the equation over here. So I have that s y2 prime prime has to also be equal to this because y2 is the solution to the equation. So what we can conclude from this is we can conclude that s prime prime y2 plus 2s prime y2 prime is equal to 0. And this gives us one important relationship. This tells me that s2 y2 s prime prime is equal to negative 2 s prime y2 prime, which tells me that negative 1/2 s prime prime over s prime is y2 prime over y2. So I know what the logarithmic derivative of y2 is from this equation. So let's take our equation over here and differentiate it with respect to x. So if we do that, what will we get? We're going to get s triple prime y2 plus s double prime y2 prime. That's the derivative of the first term over here. Plus, I'm going to have a 2 s prime prime y2 prime plus 2s prime y2 prime prime equals 0. Okay? So we can gather these common terms over here. So that's going to be an s prime 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 y2 plus 3 s prime prime y2 prime is equal to, let's examine this term over here carefully. What is this term over here? Well, this term over here is y2 double prime. I know that y2 double prime is what? y2 double prime is negative I y2. So this term over here is really negative 2 s prime and then negative I y2. So that's the negative sign right there. And then I have an I and then a y2 over here is equal to 0. And so I'm going to take that I y2 and throw it on the other side. And so what will I get? I'll get s triple prime y2 plus 3s double prime y2 prime is equal to 2s prime and then I y2, And what I'm going to do is I'm going to divide both sides by s prime y2. So if I do that, if I divide by s prime y2, I'll have s triple prime over just s prime. Just dividing by this term because the y2's will cancel out. Then I'll have plus 3 over 2, and then I'm going to have a what? I'll have a 3, rather. Excuse me. I'll have a 3 with an s double prime, so 3s double prime. And then I'm going to have a y2 over y2 prime over y2. And then I have a what? Then I also divide by I have my 3, I have my s double prime, and I need to divide by my s prime over here, like that. Now this is equal to what? This is equal to 2 times I. Now we can simplify this one final step because I know that this is negative 1/2 s2 double prime. So I know the logarithmic derivative of y2 is given by negative 1/2 s prime s double prime over s prime. So what I see over here is that this last term is exactly what? So this will simplify over here to what equation? This is going to simplify to s triple prime over s prime, and then I'm going to have a negative 3/2. I have an s prime prime over s, and then s prime prime over s, so it's going to be an s prime prime over s prime quantity squared, and that's going to be equal to 2i. So I've transformed the equation into this equation for s, and so if I can find this equation for s, I can use this to find the proportionality constants for a solution. So this expression over here, let's build some notation. I'm going to define squiggly bracket sx to be this quantity over here, this s triple prime over this differential operator s prime minus 3/2 s prime prime over s prime quantity squared. And this bracketed operator, this curly bracket, is called the Schwarzian derivative. That's the Schwarzian derivative. Excellent. Now let's do an example. This is a fun example to do. So let's do the Schwarzian derivative of tangent of x, for example. Okay. So what's my s of x? My s of x is tangent of x, so what's s prime? So the derivative of tangent is secant squared of x. The derivative of secant squared is going to be what? The derivative of secant squared is going to be 2 secant of x times secant of tangent, secant of x, tangent of x. And then the third derivative is going to be what? Well, this is going to be really, this is really 2 secant squared x times tangent of x. Okay? So what's the third derivative? It's going to be 2. Derivative of secant squared is going to be, I'm going to have a 2, then secant squared is going to give me a 2 secant of x times secant of x tangent of x. That's the derivative of secant squared. And this is times tangent, tangent of x. And then plus 2 secant squared x times the derivative of tangent, which is secant squared, times secant squared of x. That's secant to the 4th. So now I have all the terms that we need over here. So let's look at the ratio. So what is the third derivative really? So the third derivative over the first derivative, the third derivative is going to be this quantity over here. So there's a 4. And then the third derivative is going to be a 4. Then this is secant squared, tangent squared. So that's going to be a secant squared, tangent squared of x from this first term over here. And then plus 4, and then we're going to have a plus 2 rather, excuse me, plus 2. That's a plus 2. Down over here, 2 secant to the 4th of x over the first derivative. What's the first derivative going to be? So the first derivative of this thing is just going to be secant squared. So I have a secant squared, I'm going to cancel out. I'm going to do minus 3/2. The ratio of the second derivative, which is 2 secant squared x tangent x, all divided by secant squared x tangent x, all divided by s prime, which is just secant squared. There we have it. And so what we have over here is we have this, and we have to square this, of course. That's squared. And it turns out that if you do the algebraic simplification, so keep going with the algebraic simplification over here, you'll see that if you algebraically simplify this, the Schwarzian derivative of tangent is equal to 2. So it's a really cool result that basically results when you sort of simplify this a little bit. So it's a good exercise to do the simplification by yourself. You should end up with a Schwarzian derivative of tangent being 2. Thank you very much.